And I think we're on 2.7, number 6. So the last thing we did last time was talk about when you've got a couple of people doing a job together, that we have a general format that will always work with that. And that's 1 over the first person alone, his time, plus 1 over the second person's alone time will be 1 over their together time. Now when I look at this problem, number 6, it says a drain is left open as a pool is filling. Hose X can fill it in 10 hours. So hose X is 1 over 10. Hose Y is 1 over 4. But now be careful. We also, these are coming in. So think of, here's your pool. You got these 2 hoses coming in. But then there's water coming out the drain. I don't know how long it takes the drain to empty the pool by itself. That'll be X. But that's going to be a subtraction. Does that make sense to you? That these guys are working together to fill the pool. But this guy is emptying the pool at the same time. And then all together, if they're all 3 operating, it takes 15 hours. Now, does that setup make sense to everybody? Okay. What am I going to multiply by to clear out all these fractions? There are lots of common denominators, so any of them will work. What would be a common denominator?
20x.
I heard a 20. 20 would work fine for 10 and 4 and x, 20x, but it won't help me with 15. So 20 will still leave a fraction over here, which isn't the end of the world, but I might as well, yeah.
60x?
60 will work. 60 will work. Multiply everything by 60x. You need to multiply by something that will cancel out all the denominators. So 10 goes into 60, that leaves 6x. This one leaves 15x minus 60 and 4x. So 21x minus 60 equals 4x. I got 60/17 hours for the drain to empty the pool all by itself. Okay? All right, let's look at number 7. These I copied straight out of your textbook. Midtown Sports Apparel has found that it needs to sell golf hats for $275 in order to be competitive. It costs $212 to produce each hat, and we have weekly overhead costs of $3,000. Let X be the number of hats produced each week. All right. Express the average cost of producing 1 hat. All right, anybody have any ideas about this? How much does it cost to make these hats?
$2.12.
For every one of them, right? So 212x is the cost of making X hats. But if you are the business owner, you have more than 212. That is the outright cost of producing each hat. What do you have in addition to that?
Golf hats.
Overhead costs. You guys know what overhead costs are?
$3,000.
Well, yes, that's what it is specifically in this problem. But do you know what that entails? What does that include? Things like what would be in that 3,000?
Is it just like general fees on top of it?
Yeah, like what? What would
Like
be?
tax, shipping, like this. I don't know the context of it really.
Yeah, it's more, I think your overhead costs are more like your light bill, your taxes on your building, your factory or whatever. Those are costs that you pay no matter if you make a hat or not. I mean, even if you don't make a hat, you're still paying the light bill and you're still paying the water bill and you're still paying the sewage bill and all those things, repairing the roof, all those things that happen that aren't part of directly producing the hat. So each week or month, each week we spend $3,000 on our facility, and every hat we make costs us an additional $2.12. This is our total expenditure each month. So here are my fixed expenses, and then every time I make a hat, it costs me another $2.12. Now this is for X hats. This is what it costs me for X hats. If I want to know what the average is, this is the total. If I want to know what the average is, wouldn't I just divide that by X? Because dividing that by X is how I average. I take the total of everything I've got and then divide it by however many I am, in this case, making hats. So that would be our average cost per hat. Now, solve algebraically to find the number of golf hats that must be sold each week to make a profit. How do we make a profit? How do profits happen?
You make more than you spend.
Exactly. So this 212x plus 3,000 is what I am spending every month. Or every week, I mean, every week. This is how much I'm spending. How much am I making? It tells you in the problem, how much are you bringing in?
$1,000? Is that like C or?
No, I'm doing problem B. How much am I taking in? All right, how do we make money, guys? If I'm the hat producer, how do I make money?
Would it just be 2.75 times X?
Exactly. You make $2.75 per hat. So this is how much money you are bringing in. This is how much money you are taking out. So this is your income, this is your expenditure, right? If I want to make a profit, you said I want this to be bigger than this, is that right? If I'm going to make a profit, what I bring in has to be bigger than what I'm putting out. So I can solve that. looks like 0.63x is greater than 3,000. So it looks like I need to sell, oh my goodness, I need to sell about 4,762 hats. Every week. What I'm bringing in has to be more than what I'm spending if I want to make a profit. All right, and then C says, how many golf hats must be sold to make a profit of $1,000 in 1 week? So I want my profit to be $1,000. How did you say we were going to find profit? How do you do the calculation? What does that look like, profit? What you bring in minus what you put out. That's your profit, right, in this problem? This is what I bring in minus what I spend. That would be my profit. Now in problem C, I want my profit to be $1,000. So I'll set that equal to 1,000. So 0.63x minus 3,000 is 1,000. So I'm going to have to sell a lot of hats. I'm going to have to sell 6,350 hats in order to make $1,000. All right, let's do our bear hunt problem. We got a population of bears out there, and somebody has figured out that the number of bears is given by this function. It says find the population of bears when the value of t is 10, 40, and 100. Well, how would we find the population of bears when t is 10? What would we do?
Plug it in.
Just plug it in. Yeah, that's easy. Just plug it in. So, I got 200 for the first one. Let me know if I made a mistake if you don't get this. Okay, what do you think? Is that all right with everybody? Now, the next question is interesting because it looks like as we go more and more years, our bear population just keeps increasing. But the next question says, does this have a horizontal asymptote? In other words, if our bear population is increasing, does it just keep going, or is there a limit on that? Is there a boundary on that? I don't know. Let's look at our equation. How do we find horizontal asymptotes? Who remembers? You just did it on your quiz.
Take like
Well, no, verticals are what I can't be. Horizontals are when I box in the highest power of my variable. Don't I have t's over t's here? Yeah. So there is a horizontal asymptote, and where would it be?
base theory 250 divided by
500.
Yeah, it's going to be at 500. 250 over 0.5.
250 divided by 5 is 50.
It's 250 divided by 0.5. That's a point there. So 250 divided by 0.5 would be 500.
Yeah.
Now, can you explain that to me? We got a bear population here, and what we're saying is it's going to keep growing and growing and growing, but it's kind of capped at 500. Can you give me an explanation for that? Why doesn't it just keep growing?
I guess, is there like a dying population? Like, is there like a death rate too as well?
Oh, sure thing. You know, bears don't live forever. Sure, they're going to die. But it's like most every population, every organism can't just keep growing without bound, because what do you run out of? You run out of space, you run out of food, you run out of water. If you get too many people or too many bears or too many whatever, right? So it makes sense that there is a cap on that, and for this particular equation, the cap is 500. A horizontal asymptote. Good. Let's see if we get one more done. The total electrical resistance of 2 is this. One resistor has a resistance of 2.3. Let X be the resistance expressed. All right. Let's take a look at this equation. All right, so there's my total. So it says one of them is 2.3, so I'll just put that in right here. It doesn't matter. It could go in for R sub 1 or R sub 2. And X is the second one. So if I let 2.3 be the resistance of the first one, and then X be the resistance of the second one, and then R is the total. So really, that's it. That equation is it for problem A. Then in problem B says, find the resistance of the second one if the total is 1.7. So this is just like the problem where we're painting a room, only now we've got 2 resistors. But the total together is 1.7. Each one individually is, or one is 2.3 and the other one is unknown. What should we multiply by to start solving this equation?
3.91x.
Yes, that's these two times
or
each
like,
other.
Well, sorry, no. I mean, I tried multiplying both of those together to get a common denominator, but
You're exactly right, Jacob. What are you saying? That's what you should do.
well,
Well, because 1.7 times 2.3 is 3.91, and 2.3 times 1.7 is also 3.91.
Yeah, so that's what you wanna do. So this is gonna cancel and leave you with 2.3x. And this is gonna cancel and leave you with 1.7x. And this is gonna be 3.91. So 0.6x equals 3.91. And 3.91 divided by 0.6. I think our answer is about 6.52. And our unit is ohms, I think it said. Yeah. So Jacob, that was exactly right. To get a common denominator, you can always just multiply these two together. So that was a good thing to do. And that's it. Believe it or not, our time is over. So we'll stop there and pick up there next time. So don't forget your papers.
Thank you, Ms.
Don't
Ford.
forget your papers are due tomorrow, okay?
Thank you.
All right,
Thank you.
bye.
Ms. Ford.
See ya.
Have a nice day.
You too. Have a great
Ms.
day.
Ford,
Have a
Ms.
wonderful
Ford, I have
day.
a question.
Uh-huh.
So for the Thanksgiving essay, it can only be one page.
Oh
right?
no, it can be more than that.
Is that